All right, so we are doing simplification of these guys functions. Not a difficult concept. This one is simply says simplify and state the restrictions. And again, it's this one that's it's pretty straightforward. Like for example, here, what can we pull out in the numerator? Is
A
there
2.
Yeah, 2, and you're left with 3 minus 2t, and there is another 2 at the bottom like this, yeah?
And they cancel out.
Right, so the final answer is simply 3 minus 2t. Now, does this have any restrictions? What would be the restrictions here?
T can't be 3/2.
Good try, but wrong, because restrictions is strictly for the denominator. Let's try with what did you say? 3 over 2, right? Let's see if we get something weird. By weird, I mean like something over 0 or something. So 3 over 2, if t were to be 3 over 2, this goes into this twice. You'll have 6 minus 6 over 2, which is 0 over 2. It is 0. T can be 3 over 2. That is not a restriction because we got a 0. In fact, for restrictions, you would ideally just want to look in the denominator. The fact that there is no t in the denominator, that means t can be anything. There's no restrictions for t. Okay?
Mm-hmm.
Let's try B. What does this simplify to? Well, what's 9 over 6? What does that reduce to?
3/2.
Right, what about x squared over x cubed?
You just get squared.
So x squared over x cubed
It's
is...
just.
It's just x in the denominator, yeah?
Mm-hmm.
Because you bring this 2 down, it's going to become x3 minus 2x1. What are the restrictions? No? Can this x be 0?
It can't be 0.
Right, that's all, right? X can't be 0. That's all. Like here, look at C. You don't even have to do any maths. A can't be 0. If A were to be 0, you would be dividing by a 0 here. B also can't be 0. See restrictions? It's pretty straightforward. And if you want to simplify this, well, 7 goes into 21 3 times. So you have a 3 in the denominator. What's A2 over A4?
A2.
Yeah, right. A2 on the bottom, B3 over B is B2 on the top, and that's it. And these are the restrictions, okay?
Mm-hmm.
Is it difficult?
No.
Here, let's pop quiz. Gonna be difficult. For this one, you're gonna have to kind of go down memory lane if you remember. What are the restrictions for x here? It's 1 over sine x. Remember sine x?
Mm-hmm.
I don't know if we did the graphing bit, but sine x looks like this. And it keeps going till infinite in both left and right directions. This point, the angle is 90, the y value is 1. At this point, the angle is 180, y value is 0. 270, the y value is -1. So we're trying to find the restrictions of this function, yeah? So what's gonna be the idea? The idea is gonna be this. We're gonna simply set sine x equal to 0 to see what value of x gives you a 0 for the denominator. How do you solve this equation for x? So again, it's an equation. It's a one-step answer if you know what you're doing. You divide both sides by sine, okay? Because we're trying to solve for x. You divide both sides by sine. That's actually not the technical way of saying that. You're not dividing anything by sine. What you're technically doing is you're taking sine inverse on both sides, like this. You can call it dividing by sine if it helps you understand, but the technical term is you're taking sine inverse on both sides. And what happens is that this sine inverse and this sine cancels out. So you're simply left with an x on the left-hand side, and on the right-hand side, you're left with sine inverse of 0. So this is basically just telling you for what values of x is the y value 0. Look at the graph. For what values of x is the y value 0? There's one here, there's one here. There's one right there as well at 360. All these 3 points, the y values are 0. What's the x value there? No, this is the origin.
One of them is 0.
One of them is 0, yeah. What's the other one? This one. It's written
Is
right
that
there.
180?
Well, that's 180, yeah. And then it keeps going. The next one would be 360, and then you add 180. The next one would be 540. You can also subtract 180. You can go in this quadrant too. It's gonna be negative 180, negative 360. You see all these values?
Mm-hmm.
If x were to be any of these, you would get sine of, well, whatever the x value is, but that whole thing, sine of x, would be a 0, and you'd get a 0 in the denominator. So therefore, the restriction for this function, x can't be a multiple of 180. See that 180n just means a multiple of 180, and we can kind of define what n is. We can just say n is an integer. A lot of symbols here, I know, but yeah. So the only important part is this: x can't be a multiple of 180.
Okay.
Okay. The z there, this means integer. What are integers? Give me some integers.
-2.
Yeah. What about negative 5.5?
That's still an integer.
No, it is not.
Why not?
It has to be a whole number.
Oh.
That would be a rational number, 5.5 negative, but not an integer. Integers are strictly anything from negative infinity to positive infinity, but plus minus 1, increments of 1, has to be a full number, whole number. Okay.
Okay.
Rational numbers, integers are rational numbers, but rational numbers also contain other things such as negative 5.5 or anything you can write as a fraction, 20 over 7. Okay.
Mm-hmm.
Irrational numbers are numbers that you cannot write as a fraction. For example, pi, or square root of 2, or square root of 3. I don't know about square root of 3. Let me just double check. Is this gonna give us a fraction? Oh, square root of 3 actually ends, or maybe I'm in scientific notation. Let me see. There's no way that ends. Square root of 3. Nah, square root of 3 would also be an irrational number. Cool. Here, let's talk about some other random constants. You've seen pi many times, yeah?
Mm-hmm.
Pi is used in circles. There is another constant, which is called E, which is called the natural number. It has a value, again, another irrational number. It has a value of 2.717, something, goes on forever like pi. This one is used in exponential functions.
Mhm.
There's many more constants. Trying to think of some interesting ones. There's something called A, which is called Avogadro's number. And the value for this is really big. It is 6.022 times 10 to the power of 23. Now, what's so special about this one? This is more chemistry. This, you see this big number? What does that mean? If you FOIL this, it's gonna be 6022, and then there's like 20, how many zeros left? 20 more zeros. A huge number, like quadrillion, trillion, pentillion, sextillion, whatever. Okay.
Mhm.
Now, what does that number actually represent? Turns out, this is the number of molecules, okay,
Mhm.
in a substance. Well, in something called 1 mole of substance, which for us, we can just pretend it's 1 gram. It's technically not grams, but you can just pretend it's grams. So in any 1 gram of a molecule, okay, there
Mhm.
are this many, any 1 gram of a substance, for example, 1 gram of sugar. If you break this down, you're gonna get this many molecules in there, which is a huge number. Cool. Here's
Okay.
another very famous one. This one was, it was not invented, okay? There's a difference between invention and discovery. So invention would be something like sliced bread, yeah? Or
Mhm.
internet, or cars, or something like that. These are inventions. Discovery is something that already existed, but we just didn't know it for the longest time. An idea would be gravity, right? Gravity was
Okay.
discovered. It wasn't invented. Like it didn't just randomly start. We didn't start experiencing gravity in the 19th century. Invented by, not invented, discovered by very famous guy, Newton. Smart guy.
Where
You heard
would
of,
math go in this category?
it's gonna be a bit of both. I guess new math would come here, right?
Mhm.
But the value of sine 90 would be discovered. Trig was invented, I guess. Or actually, that's a good question. Is trig invented or discovered? Um, I'm gonna go with invented for that one. Because it didn't really exist before. Yeah, we came up with it, right? This is only we can understand this.
Mhm.
Think of it like this. Again, we're gonna gonna go back to aliens. So if aliens have the same thing, it's discovered, okay?
Mhm.
But if aliens don't have it, it's invented. So for example, aliens might not have sliced bread. Who knows what they eat, what they look like? They may not have the internet. Who knows what they look like, what they use, right? So anything that aliens don't have is invented. Anything that aliens could have is discovered.
Okay.
You know what happened? Here, let's go back to trig. And then I'll tell you about the other constant that I was getting at, which has something to do with gravity. So this was a hundreds, thousands of years ago, okay? Thousands of years ago. So the Greeks, okay, they came up with trig, okay? You see the
Mhm.
sine, cosine, yada yada, sine, cosine, yada yada. And they were pretty, I mean, back in the day, it would take you months to go from one country to another, okay? And then on the other side of the planet, okay, in China, turns out they also discovered trig, but they obviously didn't use the same symbols or the letters, but they used the same math, like they were doing math with right angle triangles and
Mhm.
the unit circle and stuff. So maybe this would be discovered because everyone kind of discovered it around the same time independently, funnily enough. So if we do find aliens, they would also be aware of trig, pretty sure. Because it's like the building block of civilization, right? Or like intellect, anyways.
Uh-huh.
So they would for sure know about trig. Maybe they don't use the same symbols. They for sure won't. But anyways, the
But it's
point
the
out,
same concept.
it's the same concept. Yes, they would need that to build like houses and ships and boats and whatever, cell phones. Anyways, the Newton guy, he discovered gravity. You know how sometimes people say gravity is just a theory?
Mm-hmm.
What's the logic behind that? What does it mean, just a theory? Does that mean it's fake?
No.
No, this is something called misrepresentation, okay? A theory. Oh, this is misunderstood a lot in academia, right? What do I mean by academia? I mean in literature, in science, okay?
Mm-hmm.
Theory means something that has been tested and proved. But on the other hand, in real life, you know,
Mm-hmm.
when the last piece of the pizza goes missing, you're sitting there like, oh, I have a theory about who had it. See that?
Uh-huh.
This is technically not a theory. This is just a presumption. Or the technical term for this would be something called a hypothesis. You think
Wouldn't
you
it be an
know.
inference?
No, inference requires data to back up. You need something to back it up with. This one, you have nothing to back it up with. You just have a hunch, right? It's subjective.
Mm-hmm.
So that's the difference between like theory when it comes in real life versus theory that happens in science, okay? Kind of misunderstood. So that's why a lot of like people, there's something called flat earthers, these guys?
Yes.
So these guys, they're like, oh, gravity is just a theory. It's just whatever. No, no, they think it's this. Okay, they're thinking we just kind of made it up, but turns out it's proven. Okay.
Mm-hmm.
So why is that important? It's because there's another constant called G, which stands for gravity for us. Anyways, let's just, it's not technically gravity, but it refers to gravity. And the constant is 9.81 meters per second squared. That's the value of that constant. Newton came up with it. So now what does that even mean, right? Here, I'm going to show you what that means. Gravity is just, this thing is just another way of saying acceleration. Okay,
Mm-hmm.
so let's make a chart here. Time and speed. What we're actually doing is, let's say you jump out of a plane, yeah? Let's say skydiving, whatever. Skydiving is good for this experiment. You jump out of a plane and we want to know how fast you're traveling vertically downwards, okay?
Mm-hmm.
At time zero, your speed is 0. After 1 second, your speed is going to be 9.81 meters per second. After 2, again, acceleration it adds up, okay? It adds up. After 2 seconds, your speed is going to be double of that. What's 9.8? It's going to be 19.6. See that?
Mm-hmm.
After 3 seconds, your speed is going to be 29 point something, almost 30 meters per second. Just like that. After 10 seconds, what's your speed going to be? 100 meters per second. You don't know how fast this is?
No.
We can find this out here. Quick unit conversion. We're going to turn this into kilometers per hour. And you're going to be doing this a lot. Yeah, I'm going to show you how to do this. We have meters, right? We want to kill the meters. We want it in kilometers. We have seconds. We don't care about seconds. And we want hours. Notice how the thing that I wanted to cancel out, I put them in opposite, like numerator denominators. Um, how many meters are there in 1 kilometer? 1,000, okay? 1,000 meters in 1 kilometer. In 1 kilometer, there's 1,000 meters. What about seconds an hour? What do you think? How many seconds are there in 1 hour? How many seconds are there in a minute?
60.
How many minutes are there in an hour?
The same amount.
60 times 60, there's 3,600 seconds in 1 hour, okay?
Mm-hmm.
You do this math, this thing 100 meters per second is 360 kilometers per hour. This is like almost airplane speed. So that's how fast you're falling to the ground. See that?
Mm-hmm.
This is what that tells us. I'm gonna leave you with one last idea for this topic. We will never get this fast. When someone falls, they're not gonna fall this fast because what happens is do you swim? Do you know how to swim?
Yes.
So let's say you're in water, right? You're being
Mm-hmm.
pulled down by gravity, yeah? You're
Uh-huh.
always being pulled down. But there's something called Pascal's law. I don't know if you've heard about this in grade 8, 9. Pascal's law, which says that the water pushes you back. It's called buoyancy. Okay? The
Mm-hmm.
water is always pushing you back up. So basically you float in the water. Same thing happens when you skydive. The gravity is pulling you down at very high speeds, but the drag force, air resistance, is pushing you back up. So you'll never get this fast. The maximum you can get is about 200 kilometers per hour. This is called free fall. At these speeds, even if you land in water, it would be like hitting a concrete. Water is actually stronger than it looks, right? I don't know if you've seen people like belly flop in the pools.
Mm-hmm.
It hurts. It hurts. And the higher you are,
It
the more
does.
yeah, it definitely hurts. Water has something called surface tension. It doesn't want to be penetrated. At that speed, at 200 kilometers per hour, you hit the water, it's gonna feel like concrete. If a boat hits it, it's gonna disintegrate instantly. If a plane hits it, it has hit in the past billions of pieces. In an instant. So at high speeds, water acts as concrete, okay? So that's why
Mm-hmm.
belly flopping is actually, it could be lethal. I have heard of people dying because of bad jumps. Let's say this is like a 50-meter jumping thing, yeah?
Uh-huh.
You land wrong on this, you may die. Not in like normal pools, right? We're talking about like Olympic like diving stuff. Or some like stupid people that jump off a bridge into like a river. That can be lethal. They don't know it yet. To do this, you need to know how to dive properly. Make sure you go with your hands first. Not even your legs. Legs are okay, I guess, but then what happens is that um in your nose, the water fills up and you can break your nose from inside out.
Uh-huh.
You'll definitely get a bloody nose. Anyways, those are some other constants. Let's go back to this one. And these are all going to be very, very simple. Look at this. State any restrictions. Here, look at a, x can't be plus minus 3. If it's plus 3, this one would be 0. If this is minus 3, this one would be 0. Here, what can x not be? Here, right here. What can't that be?
3/2.
Yeah, that's it, right? Easy as that. What about this one? This one's going to be a little bit trickier. It's not going to be a number. It's going to be a in terms of b or b in terms of a. The idea is the same, right? How did we get 3/2 here? We just set it equal to 0. We're going to do the same thing here. 2a minus b is equals to 0. What's a if you solve for a in terms of b? Well, step 1, add b on both sides. You'd get 2a equals b. Step 2, divide both sides by 2. So a can't be b/2. That's going to be the restriction for this guy. Okay?
Okay.
So sometimes it's going to be a proper number, but if there's a multivariable thing going on, like in this case, it is going to be 1 in terms of the other. Let's look at this one. This one we're actually going to go ahead and do this. Simplify and then state any restrictions. Can you tell me what the restrictions are right now? It's a trick question. You can't tell me right now because we need to factor this first. Okay?
Mm-hmm.
Restrictions are only visible when it's factored. Look at this. There's multiple xy's going on. No problem. Not a problem. This is just a quadratic trinomial. These are both manageable. For the top one, what does it multiply and add up to?
It multiplies to 10, adds up to -7.
What are the numeros? There's two things that multiply to 10. 1 and 10 never would add up to -7. What's the other set?
5 and 2.
Right. Which one's negative? Which one's positive? Or something else? Just 5 and 2 multiplies to 10, but doesn't add up to -7. That means we need -5, -2, okay?
Okay.
That's for the numerator. So it's, again, the leading coefficient is 1. You can straight up just do x minus, oh, you can't. Yeah, this is going to be a tricky one because there's multiple things going on there. So x squared minus 7xy plus 10y squared, you're going to have to old school this. We're going to rewrite -7xy as x squared minus 5xy minus 2xy plus 10y squared, like that. What's a GCF? What can I pull out from the first two terms?
An x.
What are we left with in a bracket?
X minus 5y.
Right, what can we pull out from the next two terms?
Two y.
So the sign is going to drop, okay? See that sign? This sign always drops,
Mm-hmm.
and yeah, it's 2y. What are we left with in the bracket?
5y.
There's going to be two terms left. The number of terms, they don't decrease, okay? You're going to be
X
left
plus 5y.
minus. These two brackets should be the same, and notice how we took out -2y. So 10y squared over -2y is going to be -5y, okay? And these two
Mm-hmm.
brackets, if you do them right, it's always going to be the same. Therefore, that whole numerator simplifies to x minus 2y, x minus 5y. See that?
Mm-hmm.
And we know the rubric, right? It's going to be x minus something y, x minus something y from the bottom one as well. Multiplies to -6, adds up to +1. What are the numbers?
Three and -2.
Right, and here's a shortcut, right? Because we're always trying to be efficient, yeah?
Mm-hmm.
Notice we already know what the pattern is. It's going to be x minus something. We know the leading coefficient is 1. So it's simply going to be x minus 2y. What are the numbers? 3 and -2, yeah. X minus 2y, x plus 3y, like that.
Okay.
Something cancels out? Yep. This is my favorite part in maths. Love when things cancel out. Finally, we're left with x minus 5y over x plus 3y. Now, what be the restrictions here? There is 2 of them. 10 points if you get them right. Now I'm going to do a side example for you. X minus 3, x plus 2. Restriction, set it equal to 0, solve for it. X can't be 3, x can't be -2. Same idea here. But in this question, you won't get it in terms of a number. You'll get it in terms of a y. Because it's multivariable.
You can't have negative x over y.
No. So you said it doesn't matter if you cancel them out. Okay. You need to include both of them. Look at this. From the first one, from the first denominator, this guy, x can't be 2y. What
Mm-hmm.
about from this guy? I mean, just solve for x
X
here.
can't be negative 3y.
There you go. 2 restrictions, 1 and done. If you don't write the restrictions, depending on how picky your teacher is, you will definitely not get full points. What happens if x were to be 2y?
You get a 0.
Yeah, you get a 0 in the denominator. In fact, in this case, here, let me tell you, actually, this is kind of interesting. So these two restrictions in this question, they have different jobs. If x is exactly negative 3y, right, for this guy,
Mm-hmm.
you'll get a 0 in the denominator. A 0 in the denominator graphically means a vertical asymptote like that, okay?
Mm-hmm.
So if x were to be negative 3y, you would get a vertical asymptote. On the other hand, if x were to be 2y, you would get 0 over 0, which is different from something over 0, okay? Now what's the
Mm-hmm.
difference? Anything over 0 divided by 0 is a vertical asymptote. 0 over 0 is a hole in the curve. There we go. That's the difference.
Okay.
Make sense?
Mm-hmm.
So even though they are both restrictions, they have different properties. Okay, let's take this up a notch because this is not that difficult. Don't worry, it will get difficult. To understand this, let's do another unit conversion. Do you know what density is?
Mm-hmm.
Density is mass divided by volume. Well, in science anyways, but mass would be in kilograms. So density is I guess how dense something is, right? But what does that even
Mm-hmm.
mean? What does how dense mean? It's relative to its volume. Okay? It is relative to its volume. And this has something to do with the next kind of off-topic things. You know a stone, right? A rock.
Uh-huh.
Why does a rock sink but a boat float?
A rock has more density.
Yeah, a rock has a higher density. The trick is to have water has a density of 1, okay, or 1,000 kilograms per meter cubed. So it's 1 grams per milliliter. So the trick is whatever your object is, if it has a lower density, it would float on water. Okay.
Mm-hmm.
Now you can use this idea to think of even like bigger objects, such as a cruise ship. Those guys, ever been on one? Those guys are enormous. Enormous things. They're basically floating islands. They can pack up to like, I don't even know actually, 20, 30,000 people at a time. It's an entire city in a boat. Okay.
Mm-hmm.
Why doesn't a
But how does
cruise,
that float?
why does that float? Exactly. That's the question. How does it float? It's gonna have a very high mass, right?
Mm-hmm.
But it also is gonna have a very high volume. You can, for our purposes, we can treat this as a rectangular prism, even though it's technically not. So the volume is gonna be LWH, right?
Uh-huh.
So it turns out for anything to float, the mass has to be less than the volume. You see this ratio, mass over volume?
Mm-hmm.
This ratio has to be less than 1 for it to float on water, which means if you multiply by V on both sides, mass has to be less than volume. So as long as you have an object whose mass is less than its volume, it should float on water. Okay?
Okay.
This thing has a massive volume. It also has a massive mass, though. That's another thing. Rock, on the other hand, doesn't have much of a volume, but has a big enough mass. If you do the math, maybe just for like a palm-sized rock, it'll probably weigh like 0.5 kilograms, yeah?
Mm-hmm.
But its volume is gonna be like 0.125 meters squared, and this ratio is way bigger than 1. That's why it sinks, and that's why cruise ships don't. What about
Okay.
us? Do we sink? Humans.
Um, I mean, we could.
No, you actually, we don't sink. Like, the only reason someone sinks is if they panic. That's the only reason someone sinks. If you go to a pool, if you know how to swim, obviously don't do this if you don't know how to swim. This is how I was taught swimming, by the way, just thrown into the deep end. So if,
Wait, really?
yeah, that's how we're old school. And in a river anyways, it's not even in a pool. But pools are chiller, it's way better. So this is the trick. If you go into the deep end of a pool and you do absolutely nothing, don't move a muscle. You can breathe, yeah?
You just float?
You just literally just float. Have you seen people sleep on water?
Mm-hmm.
Yeah, exactly. They literally just float. We float. For us, that means our mass is less than our volume. Okay?
Mm-hmm.
That's what it means when it comes to water. The only reason people sink is because they start panicking and they make these like weird motions with their like hands and legs. And then they end up swallowing water and then it's a good ta-ta for them. But eventually, once they pass out, they'll come back up and float, funnily enough.
I mean, that's how they find dead bodies, right?
Yeah. But depending on how long, how much time has passed, they're not technically dead. Maybe
Mm-hmm.
even like 10 minutes, I think, because you're gonna be brain dead, right? Um, Basically, well, the reason you die is you can't get oxygen into your brain, okay?
Uh-huh.
But our brain is meant, I mean, we've gone through evolution. Our brain is made for this. So that means is you still have some time. I think it's about 10 minutes, but obviously it's gonna vary from individual to individual. They'll resuscitate you and you'll be back. You'll be good to go. Dead bodies, for them, unfortunately, they've been in there for days. Yeah, they don't have a chance.
Mm-hmm.
Yeah, you want to know something else? How they're
Yes.
taught, how they're taught lifeguards. We're talking about lifeguards. Okay,
Mm-hmm.
they're taught to let this person drown, get to this stage. Unless they're a kid or something, then they can just pick them up, right? What happens is like the lifeguard is like this, a 16-year-old boy, and the guy sinking is like this 300-pound man. Do not go near him because what happens is he's gonna pull you down as well. You're both gonna drown, and this happens a lot in real life, not with lifeguards, but let's say your friend is drowning and you jump to save them. They're panicking, they will pull you down with them. So the trick is to just let them pass out, they'll be fine, and then you can pull them back up. And that's what lifeguards are also taught. But for children, they can't pull you down because their mass is way too little. Okay.
Mm-hmm.
And even if this does happen, the thing about lifeguards is that they have more stamina than anyone in the pool, so they can hold their breath for way longer than anyone. So even if they do pull them down, right, they can hold their
Mm-hmm.
breath for longer, and they'll be fine in the long term, anyways.
Okay.
All right, what was I trying to do? I was trying to do an unit conversion, which kind of builds up to the next section here. So density, how dense something is. mass over volume, okay? Mass is in kilograms. What's the unit of volume? The formula of volume is LWH. What are these usually expressed in? What's length usually expressed in? How wide is your table? What would you say?
I don't know.
It's about 3 bananas wide. Would that be a unit of length?
No.
Is it half a school bus wide? Would that be a unit? No, it's meters, right?
Mhm.
Meters, feet, centimeters, you can use all of them. But density, if you're using kilograms, you need to use meters, okay?
Okay.
But any of these answers would be valid for that question. Actually, I'd be fine with half a school bus wide. I want to see how big that table is. So let's do some unit conversions. Let's say we have 5 kilogram over meter cubed, okay?
Mhm.
We want to express this in grams per centimeter cubed. What is this value in this form? Now look at this. It's not that difficult, but you're gonna have to bear with me. Is this a kilogram up there? We want grams, so we need to kill that kilogram, introduce a kilogram in the denominator. Okay, we want grams, so we're gonna put a gram up top here. Same thing with the meters cubed. What do we want to do? We want to kill that meters cubed. We're gonna put that up here, and we're gonna introduce a centimeters cubed down here. Okay,
Mhm.
how many grams in 1 kilogram? You have 3 options: 10, 100, 1,000. Grams, kilograms. I'll give you a hint. Your
Is it
calculator,
1,000?
yeah, it's 1,000, yeah. So there's 1,000 grams in 1 kilogram, okay? What about
Mhm.
meters to centimeters? How many meters, I mean centimeters in 1 meter?
100?
100, yeah. But now this is the tricky part. This is what students kind of struggle with. We're gonna have to put a bracket here, because 1 meter is in 100 centimeters, okay? It's the cube.
Mhm.
It will turn out in 1 meter cubed, there is 100 times 100 times 100 centimeters cubed. And so you need to put a bracket there. And then we are just gonna plug this into a calculator. 5,000, 5 times 1,000 is 5,000 divided by 100 cubed. The answer is, I don't know why I'm in scientific notation, 1 over 200, what's that? 0.005 grams per centimeters cubed. Like that.
Mhm.
So that's how you do unit conversions, okay? This is going to be very, very important. If you ever take a science course, if you know how to do this, you're set. Because that's the trick. And there was a question like that here. See, moles, liters, same kind of idea. Mole is a chemistry unit. Mole, I don't know why it came up there, but mole is in 1 mole, there is an Avogadro number of molecules.
Mhm.
Okay, mole means just it's a little bit don't worry about that right now. All right, let's go here. Straight up, what are the restrictions? There's 2 of them, and as you can just tell by observation. Or you can turn it into a linear equation equals 0, but you don't have to. What can't x be? Look at the 2 denominators. There's 2 restrictions. Some value of x here and here would give you a 0 in the denominator. What are those numbers?
Would it be 0?
Would it be 0? X can be, no, it's not 0. some value of x would make this entire denominator 0. So we have x plus 6 squared redundant. What value of x would make the denominator 0? Not 0. If x is 0, then you would just get 36, 6 squared in the denominator. It is not 0.
-6.
Yes, -6. Look at the other guy now. What value of x here would give you a 0?
2.
Yeah, that's it. Look at the restrictions. Easy as that, right? One
Mhm.
and done. You don't even need to do any maths. But now this one's going to be a little bit trickier. How do we factor that numerator there? X squared minus 4. Use the difference of squares. Do you remember how to do that?
Mhm.
Difference of squares. It's going to be something, something. 2 brackets. It's going to straight up factor 2.
So x minus 2 and then x plus 2.
That's it, right? X minus 2x plus 2. That's factored. The bottom one is already in factored form. We don't have to touch that. Now this one, numerator, how do we factor that? X squared plus 9x guy.
You use man.
Yeah, use man. Multiplies to 18, adds to 9. What are the numbers?
9 and -2.
All right, 9 and -2 is out because that multiplies to -18 and does not even add up to 9. Try again. Multiplies to 18, adds to 9. It's not 9 and 2. You see why? Because it multiplies to -18, adds to +7. 9 and 2 is out. What else multiplies to 18?
6 and 3.
Yeah, that's it. And leading coefficient is 1. Straight up x plus 3, x plus 6, yeah?
Mhm.
On the bottom, we have 2 minus x. And again, now this part is fun. I'm itching to cancel things out. The squared cancels out with x plus 6. Anything else cancel out?
No.
No, right? But again, no, but yes. We just have to do a little bit of a cheeky math here. X minus 2, 2 minus x. Mirror images. Yeah?
Mhm.
Check this out. What happens if I have 2 minus x, if I take, or you can even write that as -x plus 2. What happens if I take out a -1? What am I left with?
X plus 2.
No,
X minus 2.
x minus 2, right? So we had 2 minus x. We rewrote that as -x plus 2. Now we're going to
You
pull
can
out
do
an,
that?
I mean, yeah, why not, right? We're just pulling stuff out. We're not adding anything. You can't just be like +2 here randomly. That's not allowed. You can't be like ×2 randomly. No, but you can definitely pull something out. And there we go. 2 minus x. We can rewrite this as 2 times -1 times x minus 2. Yeah?
Mhm.
And then boom, we have one more thing to cancel. X minus 2, gone with x minus 2. So therefore the final answer is going to be x plus 2, x plus 3, all over -2 from here. X plus 6, and our restrictions are x can't be -6 and 2. Even though the 2 guy canceled out, there's no 2 here in the final answer. It doesn't matter. You have to list the restrictions because if x were to be 2, you couldn't even go to step 2, right? The second step,
Mhm.
because the entire question would be invalid to begin with. Tell me, what kind of a discontinuity are these? Is this an asymptote or is this a hole? What happens if x is -6? Do you get an asymptote or a hole?
You get a hole?
No, whole is if x were to be 2, because you get a 0 over 0, right? If x were to be 2, you see you get a 0 here, and
Mm-hmm.
you get a 0 here. 0 over 0 is a hole, okay? It kind of looks like a hole.
And
Something
something over 0?
over 0 is an asymptote. So if you graph this, right, it'll look something like this. At -6, you'd have an asymptote, and at +2, you would have a hole. Graph is going to look something like this. How do I know that? I don't know, but that's what I would assume it looks like. Let's check it out. X plus 2, I mean, I have the book solution, right? Yeah, let's see what that graph looks like. Prediction, it's gonna look something like this. There's this thing here. There's gonna be something, well, I guess something down here, okay? Something up here, and at 2 there's a hole, and then it's gonna go like that. That's the prediction. How do I know that? I use a little trick here. I noticed that the degree in the numerator is bigger than the degree in the denominator. When that happens, you get like a slanted graph. I wish I could copy paste this, but it won't let me. Negative x plus 2, x plus 3, 2x plus 6. X plus 3 divided by 2x plus 6. Okay, no, it went the other way. Same idea, right? Notice there's like a
Mm-hmm.
little bit of like we have not seen this, have we?
No.
This diagonal, this is also an asymptote. This diagonal line is something called has a kind of like a gimmicky name. It's called an oblique asymptote. And this happens when you're doing, when you have some polynomial where the degree in the numerator, like in this case, our degree in the numerator was 2, and the degree in the denominator is 1. So when this happens, you get like an oblique, like a slanted asymptote. It's possible to find what this asymptote is as well. And you will have to do this eventually. Let's kind of just do this because why not? I'll show you how to find that slanted line. And we'll double check on Desmos to see if that's what it was. To do this, we're gonna have to do long division. Our divisor, the guy on the bottom, is 2x plus 12, right?
Mm-hmm.
Our guy on top, what is that? 5x. It's negative x squared minus 5. I just foiled the brackets, nothing fancy. Okay, like that. What goes up here?
Minus x.
Well, 2x times minus x would be minus 2x squared, which is not what we have here. There's minus x, but there's a number as well. It's not just minus x, it's gonna be minus something x. Here, solve this equation. 2x times, okay, x over something is negative x squared. You see it? X times negative x is x squared. We need to kill the 2. It's going to be negative x over 2. Right? 2x times negative x over 2 would be negative x squared. If we just have
Oh, okay.
negative x, then you get negative 2x squared, which is not what we have in the dividend. And then you got to do this with both of them, right? So 2x times negative x squared would be negative x squared over 2 would be negative x squared. And what's 12 times negative x over 2? What does that simplify to? No? 2 goes into 12 6 times. Negative 6x. Okay?
Mm-hmm.
And then we're going to subtract them. These two cancel out. This becomes a plus. Yeah?
Uh-huh.
So you get x. What now? what goes up here? It's gonna be a fraction. I'll give you a hint. 2x times something is x. It's gonna be a number, which is a fraction. It's 1/2, right? 2x times 1/2 is x, because the 2's cancel out. Do you see that?
Mm-hmm.
So that number is just 1/2 like that. And then you'll get some denominator. We're not interested in the denominator here. Unlike the factor remainder theorem, denominator is all we wanted, right? For that topic. For this topic, we're strictly interested in the quotient, and this is gonna be the equation of our asymptote. Let's try it. -x/2 plus 1/2. Erase this. And it should go right in the center of that. -x/2 plus 1/2. There we go. It'll never cross it. If you see, it'll never cross it because it's an asymptote, right? The line is not allowed to cross it. So that's how you find the oblique asymptote. You're gonna have to do long division. Cool?
Mm-hmm.
Interesting enough?
Yes.
Did I ever show you the Desmos art things?
You did.
It's a pretty powerful tool, right? Math is actually, yeah, it's it can be beautiful if you wanted to. All right, let's try doing something. All right, here we go. T means thinking. So it's not a mathematical problem, or you don't have to do much math here. You just have to show what's going on. So what's the error here? Let's go one by one, okay?
Mm-hmm.
So x is y, square both sides, good. Subtract y square from both sides, good. What happened here? Divide x minus y on both sides. That's good. Where do you think she's wrong? Because this equation, if x was 1, y was 1, the answer would be 2, not 0. And the answer has something to do with the restriction. What's the restriction in this? Look at this denominator here. What value of x would give you a 0 in this denominator?
If x was y.
X was y, right? So you see this x equals 1, y equals 1. X can't be y. They can't be the same numbers, okay? In fact, when x is y, you get a 0 over a 0 situation here. You get a hole in the curve. So that was something she didn't account for. And that's it for this.
Okay.
All right, let's call it a day.
All right. Thank you.
So yeah.